This video is about how to sew a handle shown here. I like to show many of my subscribers and others a typical small project that I do with one or two of my sewing machines. In this case I use my Singer 201K vintage sewing machine. The reason for the video is also to show how good slow speed control of a sewing machine will help you to sew projects like this. 6 handles of this kind is to be glued to the sides of an Airtrack that looks like this. Airtracks are used for tumbling in gymnastics. The weight of this Airtrack is about 140 kilograms, so this handle is supposed to withstand quite heavy loads. This is a short clip from Airtracks in use. This video got 2 parts. First parts show how the sewing machine performs when sewing this handle. The second part of the video is about the design considerations regarding this handle. The video is sectioned, so you will be able to forward the video to whatever your interest is. Base material here is a strong tarpaulin of 850 grams per square meter. Then you got this base webbing that is a dense polyester webbing of 50 millimeters in width, and then you got this same kind of webbing but 19 millimeters in width. Up here you got a tube that is 20 millimeters in diameter and 16 millimeters inside diameter. The sewing thread used is a Tex 135 polyester thread. It's from a Serifill thread. Sewing threads used for garment is normally Tex 24, so this sewing thread is significantly thicker than that. First, the webbing is sewn together. The seam here is the seam that carries all the load, and therefore I repeat sewing here 3 times. So you got plenty of sewing thread that can withstand this. When the handle is sewn to the base webbing here, this base webbing is sewn to the tarpaulin there along the edge. This is sewing these 2 layers of dense webbing. Start now. First a little reverse here, and then we go forward again. I got somewhat fixed with these clips here. The fabrics don't move. Okay, and now I turn it here, and then I make this seam here, and it needs to be a strong seam because almost all the weight will be on this seam here, so I'll actually repeat the seam 3 times. And here I move to the other part here, and then I go this direction. Okay, and I'll go there. Now I turn it around here. So I'll just check the seam here. I have lowered the thread tension a bit, and now I continue. This is the second pass here. go a third pass. Okay, so I remove these clips and then I try to continue here. And make a seam around this part of the webbing. And then we need to lock the stitch. I think I turned the fabric here. Okay. Now I'm going to sew the other side, and I got this tube on the webbing that is becoming the handle. First we lock the stitch here. Go forward. So now I'm going to sew this webbing to the vinyl below, and the vinyl is used for gluing the handle to the Airtrack. I think I'll go a little farther with the stitch length. Like that. Okay. Just check the balance. Yeah, it's okay. And then we're going to lock the stitch. Yeah. This is the handle, like you see here, and on the vinyl, and you can see the back side here, and it's made so the forces are distributed from the handle, in the best way I can. So I don't go through the vinyl on these fastenings, because I think there's webbing will be distributing the forces. I'll make a little fastening here in the middle too, because I think that could be beneficial also. I made this. On one of our Airtracks, the manufacturer had glued 6 of these handles on the Airtrack. It's a casted PVC handle, and you can find them advertised on the internet to be used on inflatable boats. However, these handles were pulled off the Airtrack after about 5 years of use. I think the glued joint starts to slip along the edge. The tarpaulin is pulled off the handle like a tape will be pulled off a hard table. I guess the inflatable boats got the same problem with these handles. Some manufacturers of Airtracks use another more flexible design of handles, and they are more durable. Such more flexible designs are also sold for boats. This is the first do-it-yourself handle I tried to make. You see that it is made so the forces are distributed to 4 webbings here, and it is actually here and here and here and here and here. These seams will take all the weight. But when you pull up to the side here, it is actually the corners here that will take all the weight. So I was afraid that this design would not be good. The stitches or perhaps the glue would slip here, and so this design I decided was not correct. So it was never used. I just made the first one like that. I then changed the design to this here. And what you see is that an added webbing base material is used. It is supposed to distribute the forces for the stitches, because it got some elasticity. So the stitches here do not go through, but is only to the top base webbing here. This handle has been used on an Airtrack for 8 years, and it is still okay. So the design should be in order. However, I discovered that when you lift hard in this handle, it becomes uncomfortable for the hand. So this is one problem, and another problem is that when you lift up like this, then it is actually the corners here that will take most of the force from lifting. So it is concentrating the force to a few stitches here. So I don't like the design because of that. That's why I decided for the design you have seen. I'll just mention the tube here that is used. It is 95 millimeters long, and it is because you can look up tables for the human body measurements, and 95% of men got the width of the hand below 95 millimeters. So 95 millimeters was chosen. This material here, you should be aware of that. This is a PEX tube that is used for heating of floors, but it is not good for UV light. So for outdoor applications you shouldn't use tube like PEX. Then you should go for PVC or CPVC tubing. They can withstand UV light. I got a few more comments to the final design here. If you look at how these webbings are going. It is like this for the first and like this for the second. And it is also to distribute the forces in the two webbings. Furthermore, you cannot say that the lift here is always upwards. It can also be to the side when you try to move the Airtrack to some position. So if you think of this as you pull the handle to the right here, you will actually get a concentration of the forces to the stitches here and to the stitches here. So you can't avoid completely that you won't get concentration of forces here. But I hope that with the 3 times the stitches and this layer, it will distribute the forces enough so we don't get any stitches fail here. Finally, I will leave a comment regarding how to glue the handles to the inflatable. You can find more videos on YouTube about this process, which is the same as to apply patches on a leaky inflatable. I use a different method which I learned from an experienced manufacturer of inflatables. The method includes pressure on the joint while the glue cures. For that I use sewn bags with sand and some other tools that you can see in this picture. I have noticed that some patches were applied without using pressure, and such patches did become leaky after some years. Below the Airtrack you got a plate of plywood, then you have the Airtrack with a handle placed here, and then you got a plastic bag on top of that. This is the orange sandbag here, and on top of that a plate and then the clamp. And when you have applied pressure with the clamp, you take a hammer and apply it to this surface, and then the sand will redistribute here so you get an even pressure on the whole surface. And then you can turn this handle again to apply more pressure. I have not seen problem with this pressure method, and I have used it for the past 14 years with more than 100 patches. I do not say that other recommended methods do not work too, but I know this works. But this pressure method do require more tools, as you can see here, to apply a durable patch to the leak. Many of the patches I have applied is placed on double curved surfaces, and then you need special tools with sandbags on both sides to make a durable patch to the leak.